Welcome back to the deep dive. Today, we are really focusing in on something fundamental to India's industrial boom. It's the specialized but absolutely critical world of aluminium extrusion. We're looking at how this manufacturing process turns, well, basic metal into the precise shapes that build so much around you.
That's exactly right. And our mission today goes beyond just looking at a technique. We're really analyzing how India's top companies are mastering these, advanced methods, how they're establishing the country as a global hub for high-quality, precision-engineered aluminum. Think of it as the backbone for everything from next-gen EVs to huge solar projects.
Okay, let's break that down a bit. For listeners who might know the term, but maybe not the nitty-gritty, what exactly is aluminium extrusion, and what does the raw material actually look like?
Right. So, simply put, you're taking these large solid cylinders of aluminum, we call them billets or logs, and you put them under immense pressure. That billet gets pushed through a die, which is basically a precisely shaped opening. And this forces the metal to take on the exact cross-sectional shape of that die. You end up with a continuous, often complex shape with really uniform characteristics. The key is achieving that high dimensional accuracy, getting profiles far more complex than just simple bars.
So pressure and precision define the process.
Yeah.
But why extruded aluminium? Why not say its heavier cousin steel? Why is it becoming so pivotal in these high-tech applications?
Well, it boils down to a unique combination of properties that steel just can't quite match all at once. First off, and probably most critical, is the strength-to-weight ratio. Aluminium is roughly a third the weight of steel. But through clever alloying and the structural design of the extrusion itself, it can be incredibly strong.
Which means, if it's so much lighter and stronger, why hasn't it just completely taken over from steel everywhere?
Yeah, good question. That's where cost and specific performance needs still make steel the right choice sometimes. But where weight is a penalty, I think anything that moves aluminum really shines. In automotive, in aerospace, this light weighting means better fuel efficiency. And crucially for EVs, cutting down weight in the chassis and body. That's essential for extending battery range. That alone often makes it an economic necessity.
Okay, that lightness makes perfect sense. But looking at the sources, another huge plus seems to be the sheer complexity you can achieve. The shapes can be incredibly intricate.
Exactly. That's the design flexibility piece. Extrusion lets engineers create these really detailed custom profiles, things you just couldn't easily do with casting or basic machining. And this freedom often simplifies assembly later on. Imagine one extruded part replacing, say, 5 different bits that needed bolting or welding.
Fewer components, fewer potential problems.
Precisely. It simplifies the supply chain, reduces points of failure, and gives you much better dimensional accuracy for those perfect fits.
You also mentioned conductivity earlier, which kind of seems counterintuitive for a structural material sometimes.
Right, but it's actually one of its key strengths. Aluminium conducts both heat and electricity extremely well. So extruded profiles are perfect for heat dissipation. Think of those complex fin designs you see on heat sinks and powerful electronics, gaming consoles, LED lights.
To maximize the surface area for cooling.
Exactly. The extrusion process makes those intricate shapes possible and efficient. And for electricity, well, it's widely used in things like bus bars for electrical transmission.
Okay, and wrapping up these core benefits, there's the sustainability angle. That must be huge, especially in a rapidly industrializing economy.
Absolutely vital. Aluminium is infinitely recyclable. It doesn't lose its inherent properties when you recycle it. This fits perfectly with the global push for a circular economy, for reducing that carbon footprint. Plus, the extrusion process itself is pretty efficient, minimizing waste. It's definitely a preferred choice for companies serious about environmental goals.
So given how critical this material is, precise, light, conductive, it must be driving innovation all over the place. Where are India's top manufacturers making the biggest waves right now?
The versatility is, well, staggering. But the automotive market, especially with the huge EV expansion, is a major driver. It's not just about general lightweighting anymore. Extruded profiles are key for core structural parts. The chassis, body frames, critical crash management system.
Why specifically those?
Because their structural integrity offers superior energy absorption and impact. It enhances vehicle safety.
And for EVs in particular, we keep hearing about thermal management.
Correct. Keeping batteries at the right temperature is crucial for their health and lifespan. Aluminium extrusions are ideal for creating these robust protective battery enclosures that are also critically highly thermally conductive.
So they protect the battery physically.
And they help efficiently channel heat away. This prevents premature degradation and maximizes how well they charge and discharge.
Okay, switching gears a bit. Let's talk construction. We all see the glass and steel buildings, but where does the specialized extrusion fit into modern architecture?
It's definitely moved beyond just standard window and door frames. You see it in complex curtain walls, facades, cladding systems, contributing to both the look and the energy efficiency of buildings. But here's something really interesting: the growing use of aluminum formwork systems for casting concrete.
Formwork, tell us more about that. Why is that specific application becoming so important for big construction projects?
Well, traditional formwork, often wood or steel, has its limits. Aluminum formwork made from specialized extrusions is incredibly durable. It can be reused hundreds of times, far more than traditional methods. Plus, it's very precise, this reusability and precision. It means major cost and time cravings on large-scale projects like housing developments or infrastructure, ensuring consistent dimensions every single time concrete is poured.
I'm also noticing it popping up constantly in highly automated settings, like industrial automation, factory assembly lines. It almost looks like high-tech Lego for factories.
That's a great analogy, actually. That sector thrives on modularity, and that's extrusion's sweet spot. Extrusions form the backbone for T-slot framing systems, conveyor frameworks, robot mounting structures, guide rails, you name it. And because they're light but strong, they're perfect for things like safety enclosures or machine guards that might need to be reconfigured quickly. That modularity saves huge amounts of time when you're retooling a factory line.
And with India's big push towards energy independence, its green energy goals must rely heavily on this material too.
Oh, absolutely. Extrusions are the go-to for solar panel frames. Why? They're lightweight, which is important for roof loading. They're incredibly durable and corrosion resistant, vital for something sitting outdoors for decades. And they're also essential for the mounting structures themselves, for both rooftop systems and those large ground-mounted solar farms.
Okay, let's pivot now from the what and where to the who. Let's talk about the specific companies in India driving this growth and precision. The sources show the Indian market is really expanding significantly. Who are the key players leading this charge?
Yeah, the Indian market is fascinating. It's a mix of, long-established expertise and some really dynamic, newer innovators. If you look at the oldest, the ones who really built the foundation, you've got Banco Aluminium, founded way back in 1967. They really stand out for their global reach, exporting to about a dozen countries and holding some very specific demanding certifications.
Certifications. You mentioned IATF 16949 before. That sounds pretty technical. What does that actually signal to someone needing reliable parts?
It's basically the gold standard for the automotive supply chain.
Uh-huh.
IATF 16949 is the International Quality Management System standard you must have to supply major global car manufacturers. If a supplier has it, it tells you they have world-class quality control, rigorous documentation, solid internal processes. So Banco, being certified, is positioned as a key supplier globally, especially in specialized areas like cryogenic transport and road transport components.
And who represents the sheer scale, the largest production capacity and widest domestic reach?
That would likely be Jindal Aluminium Limited, founded around 1970. They're a major, well-recognized player, huge product portfolio covering architectural, industrial, transport needs, really backed by massive manufacturing capability and a strong distribution network across India.
We talked about precision being crucial, like for those EV battery casings. Are there companies known specifically for hitting those ultra-tight tolerances?
Yes, definitely. That brings Valco Industries Ltd. Into the picture. They're a pioneer, actually the largest in northern India. Valco is specifically known for specializing in extrusions with closed tolerances.
Meaning?
Meaning the allowed dimensional variation is minimal, extremely precise. That kind of hyper-accuracy is vital when parts have to fit perfectly into complex assemblies, like in robotics or maybe even aerospace applications. And they ensure that quality partly by handling their own die design and manufacturing in-house.
That in-house control seems like a recurring theme for quality. What about the quality of the actual metal finish and the base material itself?
Right, which leads us to GL Aluminium Extrusion. They were one of the early adopters of ISO certification in India. A key thing for them is using an in-house foundry equipped with hot top casting technology to get superior finishes.
Hot top casting. What's the advantage there?
Essentially, hot top casting helps create a pure aluminum billet to start with. It minimizes internal defects and impurities that you might find in more conventional casting methods. The result is better performance during the extrusion itself and, importantly, a much better surface finish on the final product. And that focus on material quality seems to pay off. Their client list includes big names like Godrej, Voltus, and Tata Motors.
Okay, and finally, who are the newer players, the rapid growers making waves in this precision-focused market?
We're seeing some really fast movers. Companies like Eleanor Industries, founded just in 2017, they're heavily focused on precision, using advanced hydraulic presses. And similarly, Gloria Aluminium India, started in 2016, they have a pretty bold vision, aiming to be the largest global supplier of quality extrusions. They've invested heavily in a comprehensive tool room to back that up, speeding up development and ensuring quality. These newer companies are really pushing the envelope on scale and innovation.
This all leads to some practical insights for you, the listener. If you're a designer, an engineer, or manufacturer thinking about using this tech, what separates just a supplier from a real strategic partner? What are the key takeaways?
Yeah, this is critical. You need to distinguish between someone just taking an order and a true expert. Look for deep, industry-specific know-how. A strategic partner offers tailored solutions. They understand the different alloys, the tempers, how they perform under specific conditions. They're not just selling metal shapes, they're selling engineered solutions.
The sources really emphasize this concept of design for manufacturability, or DFM, as being key.
DFM is huge. A great partner won't just take your design, they'll collaborate. They'll give you feedback on alloy choices, potential stress points, maybe suggest modifications to make it easier or cheaper to manufacture without sacrificing performance. That collaborative approach. It saves time, cuts costs, and usually results in a better final product.
And beyond the design help, what specific technical capabilities should you look for to ensure consistent quality day in, day out?
You want to see control over the whole process. Value companies that have in-house die manufacturing.
Ah, making the shapes themselves.
Exactly. And prototyping capabilities, too.
Yep.
Keeping that in-house speeds up development immensely and gives them much tighter control over the precision and quality. Plus, they need to offer the full range of necessary surface finishing options, things like anodizing for better corrosion resistance or powder coating for specific colors and added durability.
Okay, last point here. In an industry where precision is paramount, how do you verify that commitment to top-tier quality and compliance?
You absolutely have to check their certifications, not just the basic ISO 9001 for general quality management. Look for the industry-specific ones, like that IATF 16949 if you're supplying the automotive sector. But don't stop at the paperwork. Ask about their internal quality control. How do they inspect raw materials? What in-process checks do they do? How do they test the final product? And critically, they need robust traceability systems. You need to be able to track that material right back to its source and through every manufacturing step if required.
Wow, okay. That was quite the deep dive. The big picture seems really clear. India's leading aluminium extruders are genuinely reshaping key sectors, infrastructure, automotive, green energy. They're doing it by delivering these highly customized, top-quality, sustainable profiles. It's precision engineering directly fueling industrial progress.
And if you connect that to where things are heading,
Yeah.
the sources point towards a major technological leap that's already underway. These industry leaders, they're rapidly adopting things like AI-powered precision control, they're integrating hybrid extrusion techniques, moving towards smart automated manufacturing floors.
That integration of AI and smart systems, it really positions India not just as a regional maker, but as a serious global competitor setting new standards.
Exactly. They're aiming for highly optimized automated production, minimizing error, maximizing precision. And building on that convergence, AI, smart manufacturing, material science, it leaves us with a final thought to consider. If these traditionally heavy industries are adopting high-tech control systems so rapidly for peak precision, what does that really imply for the future of specialized manufacturing globally? And maybe more importantly, how quickly will these new AI-driven standards become the expected norm everywhere?
A really profound question to think about. Thank you for joining us for the deep dive.